Welcome, engineers, to a deep dive into one of the most fundamental operations in modern computing, the syscall instruction. Understanding how applications interact with the operating system kernel is crucial for building robust and secure software. It's not just about what your code. Today, we'll demystify this critical bridge between user applications and the kernel's powerful capabilities. By the end of this lesson, you will be able to understand the fundamental purpose and role of the syscall instruction in operating systems, differentiate clearly between user mode and kernel mode, recognizing their security and privilege implications, trace the sequence of events from when a syscall instruction is executed in user space to its entry into the kernel, and finally, grasp the mechanisms by which the kernel safely exits and returns control to the calling user space application. Let's begin. At the heart of operating system security and stability lies the concept of privilege levels, primarily divided into user mode and kernel mode. Think of it like a strict bouncer at an exclusive club. User mode is where your everyday applications run. They have limited access, preventing them from directly manipulating critical hardware or memory locations. This isolation is a feature, not a limitation, as it protects the system from malicious or buggy software. Kernel mode, on the other hand, is the operating system's inner sanctum. It has full, unrestricted access to all hardware and memory. This is where the OS performs vital tasks like managing processes, memory, and I/O operations. When your application needs to do something privileged, like reading a file from disk or allocating more memory, it can't just do it itself. It needs to ask the kernel for help, and that's precisely where the syscall instruction comes in. It's the secure, controlled gateway to the kernel's power. So, how does an application safely cross that privilege boundary from user mode to kernel mode? The answer lies in the syscall instruction itself. When an application needs a kernel service, it first prepares its arguments by placing them in specific CPU registers. These arguments tell the kernel what service is requested. For example, read a file or write data.